So in the last lecture, you learned about method overriding, which basically means re-implementing a method in a child object. Now this brings us to a very important and powerful concept in object-oriented programming called polymorphism. Poly means many, morph means form. So polymorphism means many forms. It's an extremely powerful technique in object-oriented programming, as I'm going to show you in a second. So continuing from the example from the last lecture, I'm going to define a new shape object called square. So let's define a constructor square. Now, just like the circle, we want to have this square inherit from shape. So we extend square with shape. And then we're going to redefine this duplicate method on the square object. So square.prototype.duplicate. And then let's change this to duplicate square. So basically, what we have now is a simple hierarchy. On the top, we have the shape, and we have two derivatives or child objects, circle and shape. Each object will provide a different implementation of the duplicate method. So we have many implementations or many forms of the duplicate method. That's what we call polymorphism. Now, why is this so powerful? Let me show you. So let's imagine we have an array of shape objects. So let's define an array, constant, shapes. In this array, I'm going to add two objects, a circle and a square. Now we can iterate over this array using for of loop. So for, let shape of shapes, and then call shape.duplicate. Depending on the type of the shape object, a different implementation or a different form of the duplicate method will be called. So if shape is a circle, the implementation of duplicate in the circle object will be called. If it's a square, a different implementation will be called. Let's have a look. Save the changes, look in the console. Duplicate circle, duplicate square. Why is this so powerful? Well, before object-oriented programming, if we wanted to implement this logic, we would have to write code like this. So in this for loop, we would have to check the type of each object. Let's say shape, the type. If it's a circle, then perhaps we would have a function somewhere else, like duplicate circle. We would have to call that function. Now, this function is not part of any objects. It's just a standalone function. This is the non-object-oriented way of writing code. In object-oriented programming, we encapsulate our variables and functions into objects. Now, continuing with this implementation, then we would have to check else if shape.type is a square, then we would have to call a different function, duplicate square. And we could have another if statement, else duplicate shape. Now, this is a very simple program. What if we had 10 different types of shapes? We would end up with 11 conditional statements in this block. In contrast, when we encapsulate variables and functions into objects and use inheritance, we can execute many forms of a method using a single line of code. So instead of all this, it would call shape.duplicate. Isn't that beautiful? So that's polymorphism in action.